adjusted life year rather than the statistical value of being alive or not. And so then you can get people's willingness to pay for each quality adjusted life year that they get. But I think those are much less developed than these types of studies are. Now, another thing you could do is you could survey people about how much they're willing to pay to stay with their life. But I think that you'll see that those are not very reliable for some reasons we'll talk about later in the class. Okay, so let me just take a simple example of how this sort of a calculation would work, because it might be useful on your problem set. So imagine that every year, 3 in every 2,000 coal miners die, right? And suppose that factory workers have comparable skills to coal miners, but that only 1 in every 2,000 factory workers dies each year in an accident. And imagine that the coal miners earn $4,000 a year more, and that the only relevant difference between the jobs is the risk. Then the chance of the difference in the chance of death is 1 per 1,000, and in exchange for this you get $4,000, and that would imply that it's worth $4 million to stay alive. So that's basically the type of calculation that you do. And this says that the statistical value of the life for the person who's choosing between being the coal miner or the factory worker is $4 million. Does that make sense to everybody? Okay. So the real calculations that are done, even though if you look through them they'll look very complicated, are really just no more than complicated versions of this. So all that they're doing is they're trying to find people who are like as similar to each other as possible and compare the decisions that they do and control for all the differences in the different work, but basically they're just doing this calculation. And I think what's nice about looking at this is it shows you all the things that are problematic about doing this type of a calculation, but it also lets you sort of know how they arrive at the numbers. And to calculate the income elasticity, you try to look for a rich man's coal mine. So you look for something that rich people do that's somewhat dangerous. And then you try to, figure out how much they're willing to pay, take the difference between those, and then look at the difference in their income. Okay, so I doubt you can really read this very well, but this is a list of a whole bunch of studies like this that have been done. Probably the 2 most reliable ones are this Viscusi 78 and 79 and this Viscusi 81, and they find $4.1 and $6.5 million in those years. That's probably gone up by a bit because the economy's grown. So I would say that probably the value is somewhere on the order of about $6 to $10 million for a median American's life at this point. But if a median American is earning $40,000 a year, then someone earning $4 million a year, and there are certainly people like that in the United States, are probably willing to pay something like 50 times this much. Right? So their life would be worth $500 million or something. Okay. So now I want to turn to sort of the most ambitious example, probably ever, of a benefit-cost analysis, which was the Stern review of the economics of climate change. And this was commissioned by the British government along with some other international governments. And the goal was to evaluate the benefits and costs of climate change for the world. And this report proceeded in several stages. And Joa, are you here? No, she's not. Is she? No. Okay. So first, the analysis set out to determine what were the largest sources of greenhouse gases for the world. And Maria, do you remember what were the largest sources of greenhouse gas?
Something like methane. Right?
Methane's a really important one.
And
Where does methane come from mostly?
the animals.
Mm-hmm. That's the second most important one, yeah. Fossil fuels are the most important one, right? Yeah. And then the third most important one is deforestation, because the forests soak up carbon. Yeah, that's right. And then it tried to figure out what were the effects of these emissions on the global climate. And Sam, how did they do that?
They tried to use climate models.
Yeah.
But there was a lot of variables in that.
Yep.
That it talked about. So.
Yeah. No, that's right. So they used climate models, which are these giant models made by people whose job is to predict what happens to the climate when different, gases are around. And these are filled with a huge amount of uncertainty. The reason why they're so uncertain is that we have very little history of observing the global climate, and so there's very little to base these things on. So the goal was less to get a particular number of what the impact of a certain amount of gases would be, but rather to get a sense of the range of outcomes and how those shift as the gases are put into the atmosphere. And then the next goal was to determine the economic effects of these changes. And David, quote?
Yeah.
Oh, hey. What were the impacts, what were the most important economic effects of predicted global warming? Yeah, farm productivity was definitely one of the most important ones. Another one was natural disasters might increase in frequency. There's also like flooding. So as the water levels rise, they might inundate cities. Another thing that could happen is just direct harms or benefits that people don't like it to be so hot or don't like it to be so cold. If they don't like it to be so cold, that's actually a benefit. So I think Chicago might not be so unhappy about a little bit of global warming. Then they needed to figure out to what extent adaptation, that is, people like moving away from places that are likely to get flooded or away from places that are going to get too hot, might mitigate some of these harms. And Calvin, how could they figure that out, or how did they try to figure that out? Or?
Well, I suppose it's more modeling. If people change, they move somewhere else to another place, how much should they gain and how much should they lose, right?
Yeah, so that's definitely one thing you can do. You can also look at historical incidents where there was some sort of a disaster and look to what extent people moved away and that reduced the harm. So the Dust Bowl is a very good example of that. There's a famous study of what happened so the Dust Bowl was this case where basically the soil all got dried out in Oklahoma, and all these people left Oklahoma and migrated to California. And you can look at how quickly people moved out, and therefore how much that reduced the harms that were caused. One real problem in terms of that sort of adaptation making things better for climate change is that the incentives aren't really in place. So, a lot of people lived in Louisiana, even though it was incredibly prone to flooding, and we saw how bad that was in Hurricane Katrina. And one of the reasons is that they don't pay very much for flood insurance because the government just comes in and bails them out every time there's a flood rather than them actually having to buy insurance against it. So you can do similar things for other effects of climate change or even just the greenhouse gases themselves. And Shen, what were some of the other impacts of climate change beyond these direct economic effects that I was talking about?
The other environmental impacts?
Yeah,
Like desalination of oceans.
Yeah.
Would be one example.
Exactly. Yeah, so like all the carbon in the atmosphere can make the oceans much more salinic. That can kill off a lot of fish. That can destroy ecosystems, and then you can try to calculate what some of the harms of that might be. Okay. Now, corresponding to the distinction between cap and trade and calculating the optimal Pigouvian tax, there are basically two approaches to calculation that were taken in the Stern review. And Osama? Is Osama here? The first approach was to calculate sort of the marginal harm, given that the world we're currently in, of introducing a little bit more carbon. And that was a way to calculate sort of the optimal Pigouvian tax. And the benefit of that is it didn't require any estimates about the economy, really, other than just the calculations we were talking about. It didn't require any projections about how cheap it would be to reduce greenhouse gases or anything like that, right? It just required knowing what the physical impacts would be and how those would translate into economic consequences. And so this is a lot simpler to do, a lot more transparent, and requires a lot less assumptions. But the drawback is that the effects of climate change can be very highly nonlinear. That is, if we go beyond a certain point, things might really go to hell. And before that point, they might be a lot less bad. And that means that, that it might be really useful to get the right amount of carbon and try to figure out how to get there, rather than just figuring out how much harm it's going to do given the current situation. And so this led to an estimate of about $85 per ton of carbon as the marginal externality. The second approach, which was closer to cap and trade, was to actually determine what would be the socially optimal level of total carbon. And this deals with the nonlinearities that I was talking about a lot better, but it requires an incredibly detailed understanding of all the ways that we could reduce the amount of carbon and how costly those would be, so that we can do the calculation of what would be optimal. And this led to an estimate of about 450 to 550 parts per million of carbon in the atmosphere. And I think what's useful about this exercise is less the particular numbers that come out of it, but more that how it illustrates how hard it is to do one of these analyses. And this analysis had 20 of the world's top economists involved in it. The IPCC models that it was based on had 50 Nobel laureate scientists and about 2,000 other scientists involved. And still everything is incredibly uncertain, quite sensitive to all sorts of assumptions. So for example, there's these ideas about geoengineering, that what you could do is you could, if the climate starts getting too hot, you could put sulfites into the atmosphere. And these are like reflective particles that would reflect some of the sun's rays and cool down the earth. And that might, at relatively low cost, at least solve the most extreme problems. Now it might also cause acid rain and do all sorts of other bad stuff, but if we were getting into the point where we were going to go into a death spiral and the world was going to blow up because it was just getting too hot, then that could avert that. And in fact, a lot of the harms associated with climate change come from the possibility of a really catastrophic thing rather than the most likely scenarios. And so if that's able to get rid of those, then climate change might actually not be nearly as harmful as this is suggesting. So even with this incredibly detailed analysis, it was still a quite uncertain and difficult process. And it completely left out a lot of the sort of more personal or softer benefits or harms of climate, even though these could be very important or large. So for example, do people like it being warmer or colder? Do they like it being rainy or dry, etc.? And this might seem, very frivolous, who cares? But if you look at the price of real estate in Chicago and compare it to the price of real estate in San Francisco, there's an enormous difference, even though I think maybe San Francisco is a little bit cooler of a city than Chicago, but I think Chicago is a pretty cool city, and yet people are willing to pay 4 times as much for land in San Francisco as they're willing to pay in Chicago, right? So that indicates that there has to be something pretty darn good about California, and probably a large part of that is the weather, right? And so there's a question of how you quantify this. One thing you might do is compare these different land prices, but that requires an approach, and that was never done by the Stern Report. If global warming turned Chicago into California, that might bring a huge economic benefit that could offset a lot of the harms associated with this, right? Okay, so another question is, how much do people care about all the animals that might be extincted by global warming? And that